The North Central Climate Adaptation Science Center strives to help natural and cultural resource managers use actionable and open data, tools, and innovative science and information to make climate-informed decisions that support resilient ecosystems. Our major science efforts include advancement in developing quantitative future climate scenarios for assessments of ecological impacts and adaptation strategies, as well as identifying key information needs for the North Central region. These and associated efforts are built on the NC CASC's Climate Science Support Platform and have occurred through direct engagement with key partners on specific projects, like the U.S. Fish and Wildlife Species Status Assessments and scenario planning with the National Park Service. The NC CASC has developed tools like the Climate Futures Toolbox and our Shiny apps to support climate scenario planning. We have a strong research focus on ecological drought to advance understanding of drought processes and climate change-related drought risk, including the risk of flash droughts in the Rocky Mountains and Great Plains. The NC CASC has developed datasets and web tools like the Drought Index Portal, or DRIP, for users to access information of drought metrics for research and application.
The Our Shiny apps have been developed primarily to support quantitative scenario planning projects of our partners, in particular the U.S. Fish and Wildlife Service and the National Park Service. Downscale projections of various extreme climate metrics relevant for ecological applications are not easily available. So these Our Shiny apps are unique in terms of their ability to generate downscale future projections of metrics such as extreme drought events that involves use of different drought indices and metrics with the ability to quantify drought stress for periods of weeks to months. Another set of useful metrics these apps allow us to project are daily rainfall and snowfall quantities from total precipitation. We plan to develop more such apps in the future for metrics deemed useful by our stakeholders and partners.
For climate adaptation applications to natural ecosystems and species, it is critical to understand plausible ecological trajectories under different climate scenarios and inform adaptation decision-making within the Resist, Accept, Direct, or RAD framework. This is being done in multiple national parks across the nation, including at Glacier National Park.
It is critically important to understand how people and institutions make decisions about managing natural resources. And that includes understanding what types of climate information they need and how they might actually use it, but also understanding the values that inform those decisions and how people actually feel about making those decisions. Because these are not just hypothetical questions, right? They're real situations in which managers are working to prevent the extinction of particular species or the loss of certain landscapes. And as people, as human beings, we have real and deep connections to those creatures and to those places. And that's why this type of social science research is so critically important to supporting climate change adaptation.
NC CASC, in collaboration with several of its consortium partners, envisioned the Grassland Synthesis Project, which has generated 2 comprehensive reports that synthesized key information needs and future research areas to support grassland management by federal, state, and tribal agencies and NGOs in the North Central region.
Grasslands are important ecosystems because they support rural economies. They provide crucial habitat to species like the swift fox and the regal fritillary butterfly that are found nowhere else. And they also store a lot of carbon underground, which helps to mitigate climate change. Our synthesis project will help grassland managers to maintain this important ecosystem even as the climate changes. And our project does this because we really worked hard to first identify the broadly shared goals and challenges that grassland managers are facing so that the results of the synthesis can inform future actionable research that will directly support the work of grassland managers across the region.
The Future of Fire project modeled future size and number of fires, total burn area, and rates of change among years and across space in the contiguous United States. This important research will inform the National CASC's regional to national syntheses of climate change impacts on future fire regimes, management, and response efforts.
So in this work, we find that the future of fire in the U.S. will likely be characterized by more frequent and larger fires in most regions due to changing climate and more people starting fires in new places. There will be more fires in the eastern U.S., which has not experienced as many fires in the recent past, as in the western U.S., and the western U.S. will see more fires that are even larger than the largest fires in the past. These changes have major implications for the ecosystem and fire management, disaster response and mitigation, and future public policy.
The NC CASC links data, discovery, and decisions through co-production in order to deliver actionable climate and global change information for key resource management challenges in the region. We provide science, training, and synthesis that is directly relevant to the decisions being made by resource managers, and to build the next generation of climate-smart, data-capable, and engagement-savvy resource managers and scientists. These efforts constitute the collective climate services that the nation needs to adapt and thrive in changing conditions.